Welcome to the last day of our Algebra 2 Chapter 11 videos. This is Mrs. Roberts, and this is Measures of Central Tendency. Now, that may sound like a big thing, but it's really stuff that you've seen before. So we're going to calculate measures of central tendency. Some of the ones that you probably already know, but I'd like you to go ahead and put these in your notes, would be mean, median, and mode. Mean is the sum of the values divided by the number of values. It's also called your average. Median, that's the middle number or the mean of the two middle numbers if there's an even number when they are in numerical order. This is extremely important that they be in numerical order. Mode, that's the value or values that occur most often. You may have one mode, you can have no modes, you can have several modes. It just depends on how much data you have. Okay? If you didn't get all these down, pause it. We've got one more screen of notes to take. All right. We're also going to talk about a box and whisker plot. You have probably been doing box and whisker plots for a long time. They're used to show the spread of data, and it has these key components on it. It has the minimum value, which is the least, the first quartile, which is the median of the lower half of the data. You do not use the median when you're calculating it. The median, which we already said was the middle value. The third quartile, which is the median of the upper half of the data, and again, you don't use the median. And the maximum value. Those things are displayed. And then you can also calculate the interquartile range. That is the difference between the third quartile right here, and the first quartile right here. Median is in the middle, third quartile, first quartile, minimum is the smallest, maximum is the largest. Now, they are not always spaced out equally. Interquartile range is the difference between your third quartile and your first quartile. Make sure you get these down, and we'll look at some examples. Okay. It says find the mean, median, and mode of the data at a deer feeder each hour. Well, first thing, if we have to find median, we're going to have to put things in order from least to greatest. So I've got a 0, and I would encourage you to mark them off as you write them down. I've got another 0. That way you know you haven't missed any. I've got a 1. I've got a 2 and then another 2, so I'm going to mark both those off. And then I have a 3 and a 4. So I've got my 4, I've got my 3. I've got 1, 2, 3, 4, 5, 6, 7 pieces of data, and I still have 1, 2, 3, 4, 5, 6, 7. So the mean is the sum of all those pieces divided by the total number. So 0 plus 0 is 0, plus 1 is 1, plus 2 is 3, plus 2 is 5, plus 3 is 8, plus 4 is 12. So 12 divided by 7 is my mean. I can calculate that. 12 divided by 7 is 1.71. That means on average, I see almost 2 deer per hour at my feeder. Median, remember, is the middle. Now, some people like to do it and think 1, 2, 3, 4, 5, 6, 7, and they count in. And so you've got a 4 and a 0. You've got a 3 and a 0. You've got a 2 and a 1. What is the middle term? The median is 2 because it is in the middle of that data. Now, if you look, you should have 3 on this side of it and the same number on that side of it, which we do. And that's what you need to be careful of when you have the median. Now, let's get rid of that eraser there. And get rid of all that mark, so that we can see our median. Now, our mode is what occurs the most often. Well, in this case, we have 2 modes because we have a 0, which occurs twice, and a 2, which occurs twice. Since they occur the same number of times, we put both of them down as our mode. All right. Now, we're going to do some of these same things to create a box and whisker plot. We do not need the mean for the box and whisker plot, but we do need the median, and we need the first quartile and the third quartile. And then we will put in our box. Now, before we do anything, again, we've got to get these in order from least to greatest. The smallest one up there is a 4. Then we have a 5. Then we have 6. And we have another 6. We have 7. we have an 8, and we have another 8. We have a 9, and we have a 10. That's all of our data. All right, I want you to find the median first. Pause it, find the median, and then check and see if we found the right one. All right, what did you find for your median? Well, if we think we've got a 4, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. What would be the middle? It would be our 5th term, or if you think about crossing it off in the end, we cross off the 4 and the 10, cross off the 9 and the 5, cross off the 8 and the 6, cross off the 8 and the 6, and that leaves us with the 7 in the middle. Now, there's 4 terms on this side and 4 terms on this side. The median should always have the exact same number to the left of it as it does to the right. So our median is 7. Now, we're not being asked to find the mode, and we're not being asked to find the mean for the box and whisker. Now, I'm going to label, let's see, we've got a minimum of 4. We've got a maximum of 10. So we've got our number line to label here. Let's see, 1, 2, 3. So we've got plenty of room here. Let's start here with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. We also have to find our first quartile and our third quartile because those are the ends of our boxes. Now, the first quartile is the median of these 4 things. Well, let's take a look. We've got 4 items. So what would be the middle of those 4? It would be right there in between, because if I think of the 4 and the 6 is making a pair, 5 and 6 is making a pair, I've got to find that number. How do I find that number? It is the average of these 2. So what's the average of 5 plus 6 divided by 2? That would be 5.5. Same thing here. Got to find the median of these 4. Notice I did not count this 7 when I was looking at these. This is my first quartile. This is my third quartile. Again, we find the average of these 2. What's the average of 8 and 9? 8.5. These are the ends of our boxes. So we have a line here at 5.5. We have a line here at 8.5. And we're going to draw a rectangle. That's our box. Now we have to put the median in our box, and we draw it right over the 7. And so there's our Q1, there's our median, and there's our Q3. Now remember, we also need our whiskers. We have a whisker out here at 10 and a whisker over here at 4, and we connect it to the box. Now the other thing that we can figure out would be our IQR, or interquartile range. That is Q3 minus Q1, which is 8.5 minus 5.5, which is 3. It says this from quartile 1 to quartile 3 is 3 units. And it just tells us how far apart our spread is. It tells us if our quartile 1 and quartile 3 are close to each other or if they're spread further apart. Okay. Now, we can also use the measures of central tendency to solve problems. It says Billy's score is 80%, 90%, 66%, and 65% on his first 4 tests. What must he score on his last test to raise his grade back up to a B minus? All right, so he wants his final grade to be an 80%. How do we find the average? Well, we add all the things together. So we have 80 plus 90 plus 60 plus 65. But we also have to put in an X because we don't know what he's going to get on his last test. He's trying to figure that out. How many things are we adding? 1, 2, 3, 4, 5. We are adding 5 things. So let's add all this up together. And when we do that, we get 80 plus 90 plus 60 plus 65 is 295 plus X over 5 equals 80. How do we solve this? We have a number in our denominator we need to get rid of, so we have to multiply it. But if I multiply this side by it, I have to multiply that side by it. The 5's will cancel, leaving me with 295 plus x equals 400. Oops, this should have been a 66. Did you catch my mistake? So instead of being 295 here, what should that be instead? Looks like I'm short by 6. So instead of being a 295 here, this should be a 301. So if we solve, we get x equals 99. And these were all percents. So Billy has to get a 99% on his last test if he wants to get an A minus, or excuse me, a B minus in the class. It's going to have to work pretty hard, isn't he? Okay. So those were some, went very quickly over those because I know that you remember mean, median, and mode, and you've done those for a while. We also have what's called a probability distribution. It works with the means and the medians and the modes in some way. It works with our means, actually, is what it does. Only it's a weighted average of all the outcomes. So probability distribution is the function that pairs each outcome with its experiment. It's something that actually happens, and the expected value is the weighted average. A weighted average is a mean calculated by using the frequencies of certain data values. Okay, suppose that 30 movies are rated as followed. 8 movies receive a 4-star, 12 movies receive a 3-star, 7 movies receive a 2-star, 2 movies receive a 1-star, and 1 movie receives a no star. Well then, if we look at this, what we get here is a weighted average. Okay, we take 8 movies at 4 stars, so we take 8 times the 4 stars. We had 12 that got a rating of 3, so we take 12 times 3. We have 7 that got a rating of 2, so we take 7 times 2. We had 2 that got a rating of 1, so we take 2 times 1. And we had 1 that got a rating of 0 stars, so we take 1 times 0. We add all those possibilities up, and we divide it by the total number of movies. Not 5, because that's the categories, but we have to add all of the categories. So we have to add 8 plus 12 plus 7 plus 2 plus 1. We get 84 out of 30 equals 2.8 stars. That's the average rating for these 30 movies would be 2.8. So about in here. All right, so let's have you try one. Probability distribution of successful free throws for a practice set is given below. Find the expected number of successes for one set. So when we have 0 throws, the probability is 3 out of 20. When we have 1 throw, we get also 3 out of 20. 2 throws, 1 out of 5. 3 throws, 1 out of 2. So can you set this up, try it, and then check back with me? Okay, so let's see how you did. So we take 0 times 3/20 plus 1 times 3/20 plus 2 times 1/5 plus 3 times 1/2. All I'm doing is I'm taking the number times the probability, number times the probability, number times the probability, number times the probability. Then I'm going to add those up, do the multiplication, add it all up, and divide by the total number of free throws. So I have 0 plus 1 plus 2 plus 3. So when we add up the denominator, we get 6. This is 0, so we don't have to worry about that. 3/20 plus 2/5 plus 3/2. Now, remember, to add add fractions, we have to have like a common denominator. Common denominator would be 20. So I can multiply this one, the 2/5 times 4, in both the top and the bottom. and the 3/2 times 10. So I'm going to do that. I'm going to take this times 4 over 4, and this one times 10 over 10, so that I can get a fraction that I can work with. So I have 3/20 plus 8/20 plus 30/20 all over 6. Now I have a numerator. I can add my numerators because I have the same denominator. 3 and 8 is 11 plus 30 would be 41 out of 20 divided by 6. But now I have this fraction in a fraction. Well, remember, when we divide by a fraction, it's the same thing as multiplying by the reciprocal, but we need to think of this as being 6 over 1. So that's 41. Let's make that a 41, not a 14. All right, let's try that again. We have a 41 out of 20 divided by 6 over 1, which is the same thing as multiplying by the reciprocal, which is 1 over 6, which is 41 out of 120. That is the probability, expected number of successes for that. All right, so for tomorrow, I want you to summarize what you've learned and write at least one question you have about the lesson. Have a great night.